Number 6. Sketch the graph of f of x equal to negative 4x squared minus 6x plus 2 by determining the following. So the first thing they want us to do is determine whether or not the graph opens up or down. And we can do this by simply looking at our equation. So our equation, we're going to look at our leading coefficient here. So this negative 4. So since our leading coefficient is negative, it opens down. So then it wants us to find the vertex of our parabola. Well, we could do this a few different ways. We could complete the square in this function, or we can kind of take the backdoor way and calculate the vertex directly. And that's actually my preferred way to do this. So that's what we're going to do. So usually the vertex is referred to as the point HK. Well, we can calculate h using our function as minus b over 2 times a, where of course that comes from the coefficients of our function. So my b in my function is negative 6. So I'm going to take the negative of negative 6, which is positive 6, and divide that by 2 times a, my leading coefficient, which is negative 4. So it's going to give me 6 over negative 8, which will reduce to negative 3/4. So that's going to be the x value of our vertex. So then we want to find the y value of our vertex. Well, it's going to be our k. And we can find k by plugging in whatever we get for minus b over 2a back into our function, which is really nice. So I'm going to find out what f of negative 3/4 is. So that's going to be negative 4 times negative 3/4 squared minus 6 times negative 3/4 plus 2. Well, negative 3/4 squared is going to give me 9/16. And then negative 6 times negative 3/4 is going to give me 18 over 4. And then we still have plus 2. Well, 9/16 times negative 4 will give me negative 9/4, because a factor of 4 will cancel out in that 16. And then I still have plus 18/4. And then since I'm going to be adding these two fractions with this whole number, I'm going to go ahead and find a common denominator. Since both of these fractions already have a denominator of 4, I'm going to go ahead and keep that the same way. So what divided by 4 will give me 2? Well, that'll be 8. So then all I have to do is add up my numerators and put it over 4. Well, negative 9 plus 18 plus 8 will give me 17. So my vertex will be the point negative 3 over 4, 17 over 4. Then it wants us to find any x-intercepts, if they exist. So there's many ways we could do this. We could try the good old factoring after we set this equal to 0. We could complete the square, or we could use our quadratic formula. So the first thing I'm going to do is set my function equal to 0. And then usually I will go either the good old-fashioned factoring or the quadratic formula. I usually don't use complete the square unless I absolutely have to. Well, I don't see how this factors without putting in a lot of extra work. What I'm going to do is go ahead and use our quadratic formula. So our quadratic formula is x equal to minus b plus or minus the square root of b squared minus 4ac all over 2 times a. Now, if you're going to use your quadratic formula, make sure you are 100% sure what it is. Because unfortunately, I do have some students who will forget that 2a at the bottom, and it does give you the incorrect answer. All right, so that's going to be x equal to 6 plus or minus the square root of negative 6 squared minus 4 times negative 4 times 2, all over 2 times negative 4. Well, negative 6 squared is going to be 36. And then negative 4 times 2 will give me 32. All over negative 8. Well, that's going to give me 6 plus or minus the square root of 68 over negative 8. And then the square root of 68 will reduce to 2 square roots of 17. And then I'm going to go ahead and split up that plus or minus to make it easier for us to find our answer. So x equals to 6 plus 2 square roots of 17 over negative 8. And x equals to 6 minus 2 square roots of 17 over negative 8. And then we can reduce a little bit, because I have a factor of 2 in all three of my numbers. So x equals to 3 plus the square root of 17 over negative 8. Negative 4. And x equals to 3 minus the square root of 17 over negative 4. And unfortunately, they're not going to get any prettier. So then part D, our y-intercept. Now when we're given our function all multiplied out for us, or in an expanded form, it's really easy for us to find our y-intercept. That's going to be this number over here all by itself without an x attached to it. So our y-intercept will be 2. But if you forget that or aren't comfortable using it, you can always go about it the good old-fashioned way, by setting x equal to 0 and solving for y. So I'm going to go ahead and show that down here. Alrighty, so 0 squared is just going to be 0. And then negative 6 times 0 will be 0. Well, negative 4 times 0 is going to be 0. So I get y equals to 2 for my y-intercept. And then we can actually graph our function. So we actually have all the information that we need in order to graph our function. We have our vertex, we have some intercepts. We should be good to go. Now there will be times where we won't have an x-intercepts at all. So it may be easier for us to find some extra points, but not completely necessary. Now we will need to graph these x-intercepts. So it may be easier for us to put them in decimal form first. But we want to make sure we give our answer in that fractional form so we get the entirety of our points. So 3 plus the square root of 17 over negative 4 gives me roughly negative 1.78. And x equal to 3 minus the square root of 17 over negative 4 gives me roughly 0.28. So that'll be a little bit easier for us to graph. It would also probably be easier for us to get our vertex in decimal form. So negative 3/4 will be negative 0.75. And then 17 over 4 is 4.25. So I'm going to start out by graphing that first. So that's my vertex there. And we can go ahead and plot our x-intercepts and our y-intercept. Our y-intercept was just 2. And then our x-intercepts were negative 1.78, so right about there, and 0.28, so right about here. And then it opens down, so it should look something kind of like this. Now, we're not looking for perfection with these graphs, but be warned, especially if you're in my class, if you give me just a V like this, you're not going to get full credit. Our parabolas do have a curve to them, so keep that in mind when you're creating your graph.